ferrium Fe, and copper cuprum Cu. Its Latin name is cuprum, so Cu. Silver argentinum, so Ag. Gold aurum Au. Mercury hydrogium, so Hg. Lead plumbum, so Pb. Tin stannum, Sn. Antimony stibium, Sb. Tungsten wolfram, so W. So like Greek and Latin names are given for the element symbol. In the fifth step, we come to know some elements are named using the name of the country, scientist, color, mythological character, planet, etc. So these are all the example for them. See, Americium AM, named after the country America. Europeum, Europe, named after the country. EU is the symbol. Nobelium, NO is the symbol. It is named after the scientist Alfred Nobel. And iodine, the symbol is I. In Greek, the name of the color violet is iodium. So Mercury, god Mercury, the mythological character, Hg is the symbol. And plutonium, neptunium, uranium, the symbols are Pu, Np, U. They are all named after planets. Okay. So what is the gist in writing the symbol? First thing, if the element has a single English letter as a symbol, it should be used in capital letter. Secondly, for elements having two letter symbols, the first letter should be in capital followed by the small lowercase letter. Okay. Now next we need to see metals and non-metals. So the progress of man towards civilization is linked with the discovery of several metals and non-metals. See, we can classify the history of mankind as Stone Age and Metal Age. So the Metal Age can be further classified as Bronze Age, which is followed by Iron Age. If you see the history, after the civilization gradually grew based on the invention of some metals. Okay, so even today, the possession of the metal is the index of some countries or countries' wealth. The wealth of the country is measured by the amount of gold in its reserve. For example, our money value is lowering means the rate of the gold is rising. Nowadays, the rate of the gold rate is higher just because the money value is low. So we reserve very much less amount of gold compared to United States of America. So the money value, our money value is getting lower. Okay, so it is determined by the metals possessed by a particular country. So metals have some characteristics, some properties. Similarly, non-metals also have some properties, its own characteristics. When if we find a new element, we have to put them into the metal category or into the non-metal category. So we have to compare the properties of that newly invented element. In such cases, few elements will not follow the properties of metals as well as non-metals. So they are further classified into another classification called as metalloids. So totally we can classify the elements into three types. One is metals, another one is non-metals, the third one is metalloids. First we are going to see the properties of metals. Let's know the examples of metals: iron, copper, gold, silver, etc. These are all the metals that we use our daily life. Now let's know the physical properties of metal. In anything, in chemistry, you have to know both physical as well as chemical properties of metal. We are entering into chemistry, so metals. In this lesson, we just bother about physical properties alone, but always the chemistry deals with physical property and chemical property. Mind about it while you learn chemistry. But in this lesson, we are dealing only the physical properties of metals. Okay. What are the physical properties of metal? First, metals are solid under normal conditions of temperature and pressure. You can see many metals, all the metals are solid. Only metal which is in liquid form is mercury, which is used in the thermometer. Inside the silver like liquid, isn't it? That is known as mercury. That mercury is a metal, but it is in a liquid form. But all the metals are in solid form. Second thing, most of metals are hot. All the metals are very hot. Thirdly, the metals are shiny. The typical shine of metal is called metallic luster. All the metals are shining. Metals generally have high density. Their density is high. They are tightly bound together. Their atoms and molecules are tightly bound together, so they have very high density. Metals in general have high melting point and boiling point. Yes. While we heat that's why we are using metal for cooking. They cannot easily melt. Yes. So we are using metals for cooking. So they have a very high melting point and very high boiling point. I hope you all know what is melting point, what is boiling point. I just would recall you using a candle. When it started to melt, that temperature is known as melting point. At which temperature the solid turns into liquid is known as melting point. Boiling point, the temperature at which the liquid is transformed to air or vapor is known as the boiling point, the temperature. Okay. And the next point, metals can be hammered into very thin sheets. See, nowadays we are using aluminium foils, isn't it? Aluminium metal is that much malleability, having that much malleability that can be spread into very thin sheet. This tendency of metal is called malleability. Using this property, aluminium is transferred into silver foils. Yes, we are using nowadays aluminium foils. Yes. I would like to tell you what is malleability. Wait. This is malleability. Malleability is a physical property of metals that defines their ability to be hammered, pressured or rolled into thin sheets without breaking. Without breaking, it can be spread into thin sheets in any manner, like hammering, pressing, rolled. Any physical method we can follow, we can spread them into thin sheets. In other words, it is a property of a metal to deform under compression and take a new shape. A metal's malleability can be measured by how much pressure it can withstand without breaking. It should not break. That is the important point. Difference in malleability among different metals are due to variance in their crystal structure. Like aluminium foil, we cannot spread iron. So that depends upon their structure. Okay. In the next point, you come across a word known ductility. So let's know the meaning, then later we move on to that point. While malleability is the property of a metal that allows it to deform under compression, this ductility is a property of a metal that allows it to stretch without damage. You can stretch. Copper is an example of a metal that has both good ductility and good malleability. It can be stretched into wire. It can also be rolled into sheets. So ductility is like a thin wire. Gold, it has a very good ductility. Copper have both the malleability and this ductility property. So let's move on to the next property of metal. Metals can be drawn into thin wires. This property of metal is called ductility. Example, copper wires. Generally, metals are good conductors of heat and electricity. Metals can conduct heat as well as electricity. That's why we are using metals for cooking and also for electric transformation. On being hit, metals produce a typical sound. Hence, they are said to be sonorous. What do you mean by sonorous? Capable of producing deep sound. Capable of producing deep sound is known as sonorous. This sonorous, the property of producing deep sound. This property is being made use of making bells, etc., temple bells, etc. Okay. What are all the uses of metals? Next we are going to see. Iron is used for making bridge engine parts, iron sheets and bars. Copper is used for making electrical wire, coins and statue. Silver and gold are used for making jewels and for decorative purposes and photography. Mercury is used in thermometer and barometer because of its high density and uniform expansion at different temperature. Aluminium is used in electrical wires, cables and in aerospace industry. Lead is used in automobile batteries, X-ray machines. So these are all the uses of metals. Next we need to see about non-metals. Elements like sulfur, carbon, oxygen are non-metals. Some of the properties and uses of non-metals are given below. The properties of non-metals are merely opposite to the properties of metals. Let's see their property. Non-metals occur as solid, liquid or gases at normal temperature. See, the metals occur only in solid, mostly solids. Metals are mostly solids. Here the non-metals can be solid, liquid and gases. Okay, for example, sulfur, phosphorus occur in solid form. Carbon dioxide, oxygen, nitrogen, etc. occurred in gaseous form. Bromine occurred in liquid form. Okay, non-metals are generally not so hot or generally not hot except diamond, which is the form of carbon. Carbon have different forms. One form is diamond. This diamond is only hardest non-metal. Remaining non-metals are not that much hot, not generally hot. Non-metals have dull appearance except diamond. Diamond only shines, but non-metals have very dull appearance. Non-metals are generally soft and have low density. The exception here is diamond, which is the hardest naturally occurring substance. The hardest naturally occurring substance is diamond, okay, which is the form of carbon. See, I repeatedly mentioning about the carbon. There is a reason behind it. Non-metals have low melting point and boiling point. We saw metals have high melting point and boiling point. Here non-metals have low melting point and boiling point. Non-metals are non-malleable. Here we have seen metals have malleability. Non-metals are not ductile. Carbon fiber is highly ductile. Exceptional case is carbon. Exceptional case is carbon. Carbon fiber is highly ductile. Other non-metals are not ductile. Non-metals are generally bad conductor of electricity. Exceptional case graphite. Graphite is a form of carbon. So all the carbon forms, graphite, carbon, diamond, these are all the forms of carbon. These are all the exceptional cases in non-metals. But we keep carbon in non-metals. Okay, they exhibit the nature of metals in few cases, but we keep carbon in non-metals. Okay, non-metals do not produce sound. Non-sonorous, that is known as non-sonorous. They do not produce sound. In activity 2, they have explained you what is sonorous. Okay, I would like to explain you about the activity 1. Take a battery, few wire pieces, a bulb, a nail and a pencil lead. First connect the nail in the circuit and shown in the figure. What will happen? Nail is a good conductor. It is made up of iron, so the bulb will glow. The nail also conduct the electricity. So through this nail, the bulb will flow. If I replace this nail with a pencil lead, what will happen? Whether the bulb will flow or not, glow or not. In this case also, the bulb will glow. Even the pencil lead is a non-metal. It is made up of carbon, which is a non-metal. The bulb will glow because this pencil lead is made up of graphite. Pencil lead is made up of graphite. Even it is a non-metal, it conducts electricity. Let's see the experiment now. See here, we have taken a sharp pencil. So both the side is sharpened. What is that? Graphite. Inside the pencil lid is graphite. 9-volt battery is taken and a LED bulb is taken. All are available in your nearby shops. You can do it at your home. No problem. It is advisable. It is not so harm. So you have to connect the battery with the LED bulb. So it glows. So we are changing the connection via this graphite to know whether it can conduct electricity or not. See properly. If the connection is done well, see the bulb is glowing. So the graphite is a good conductor of electricity, even it is a non-metal. Even it is a non-metal, it conduct the electricity in a very good manner. Yes. You can do this experiment by scratching the pencil lead on a piece of paper and give the connection in that paper. The light will glow on the graphite side. Okay. Also, if you powder this graphite and put inside the water, the electricity will pass through that water also. Okay. If even though it is a distilled water. Okay. So the graphite, even though it is a non-metal, it is a very good conductor. That's what they try to explain through this activity 1. Next we need to see metalloids. The elements which exhibit the property of metals as well as non-metals are called metalloids. Examples: boron, silicon, arsenic, germanium, antimony, tellurium and polonium. These are all the metalloids. Now let's know the physical property of metalloids. Metalloids are solid at room temperature. They are solids at room temperature. They can form alloys with other metals. Some metalloids, for example, alloys example என்ன சொல்லலாம், sterling silver we used to wear in your stud earring bracelet etc. No, it is the alloy of silver and copper, gold, silver. These are all the example for alloys. Okay. Some metalloids such as silicon, germanium can act as electrical conductor under specific condition. Thus they are called as semiconductors. So the semiconductors very peculiar property of the metalloid, semiconducting. Okay. Silicon, which is a metalloid, appears lustrous, but it is neither malleable nor ductile. What do you mean by lustrous? It is shining. Silicon appears shining, but it is neither malleable nor ductile. It cannot be spread as a sheet. It cannot be spread as a thin wire. It is brittle in nature. Brittle means it is hard but easily broken. Brittle is it is hard but easily broken, which is the characteristics of some non-metals, but it is a very much poor conductor of heat and electricity than the metal. These metalloids are very much poor conductors of heat and electricity than metals. The physical properties of metalloids tend to be metallic, but their chemical properties tend to be non-metallic. So in their physical property they exhibit the nature of metallic. In their chemical property they tend to exhibit the nature of non-metallic. What are all the uses of metalloids? Let's see. Silicon is used in electronic devices. These are all the semiconductors, silicon and germanium. The semiconductors and semiconducting devices you might have learned in your higher studies if you take select science group. Very interesting. Conductors and semiconductors, very interesting session. It is a separate vast huge session in physics. Okay. So silicon is used in electronic device. Boron is used in fireworks and as fuel for ignition in rocks, making something start to burn. That is known as ignition. What do you mean by ignition? Making something start to burn is known as ignition. So till now we come to know what are metals, non-metals and metalloids, their properties and their uses. Next we need to learn about compounds. We shall see it in a separate video.